In the vast expanse of the night sky, amidst the many twinkling stars and distant galaxies, there exists a celestial beacon that has captured the imagination of explorers, sailors, and dreamers for centuries. This guiding light, steadfast and unwavering, is none other than Polaris, the North Star. But lately there have been some reports that something strange is happening to our guiding light in the night sky. So what is all the recent hype about? We'll take a look at what researchers are saying. Get ready to join us on a mesmerizing cosmic journey to the North Star and find out what astronomers are now saying about the strange and unknown things happening to Polaris. Logo: Polaris, also known as Alpha Ursae Minoris or Alpha Michigan for short, is a moderately bright star, the 48th brightest star in the Earth's night sky that has a slightly yellowish hue. Its location near the celestial North Pole allowed sailors and explorers to establish true north, crucial for charting courses and navigating across oceans and uncharted territories. Polaris appears motionless in the night sky because it aligns almost perfectly with the Earth's axis of rotation. Imagine the Earth's axis as an imaginary line running from the North Pole to the South Pole. Polaris is situated very close to this line, and as a result, it remains nearly stationary in the northern celestial hemisphere. This alignment gives it the appearance of standing still while the other stars seem to revolve around it. However, the Earth does not rotate on its axis like a perfect top. It experiences a slow, gradual wobble known as axial precession. This wobbling motion is caused by gravitational interactions with the Sun and the Moon. Over a span of approximately 26,000 years, the Earth's axis traces out a circular path, much like the slow rotation of a spinning top that's starting to lose its balance. As Earth undergoes axial precession, the orientation of its axis changes relative to the background stars. This phenomenon has several consequences, one of which is the shifting of the position of the North Star over long periods of time. While Polaris is currently our North Star, due to the Earth's wobble, in about 13,000 years, another star, Vega, will take on this role. The place in the sky that the Earth's North Pole points to also changes slowly over a vast amount of time. Researchers call this movement stellar precession. Back in 3000 BC, a faint star called Thuban in the constellation Draco was the North Star around the same time the Egyptians built the pyramids. It wasn't until about 500 AD that Polaris became the North Star. As time passes, it will move closer to the Earth's North Pole until it is directly above it sometime in the year 2102. Then it will start to move away again, but remain the closest star to the North Pole until 3000 AD. Some of you may be asking by now, well, how do I find the North Star? Well, that all depends on where you live on planet Earth, as in some places it cannot be seen. If you've been watching our channel for some time, you're now probably familiar with the constellations, those groups of stars in the night sky that resemble earthly objects or mythical figures. So now we're going to make you an expert at finding a couple of these constellations, and thereby locating the North Star so you can impress your friends and family. There are a couple of ways to find the North Star. The first way is to locate the constellation known as the Big Dipper. This constellation has the distinct shape of 7 bright stars that resemble a ladle or a scoop. It is actually quite easy to find, and most stargazers can identify it quickly in the night sky. Within the Big Dipper, identify the 2 stars at the end of the cup-shaped bowl opposite the handle, which some astronomers and stargazers call pointer stars. These stars, Merak and Dubhe, point toward Polaris. Now keep in mind the length between these 2 stars, and draw an imaginary line from Merak through Dubhe, and go about 5 times that length outward. If you did this correctly, you should see a fairly bright star twinkling in the night sky above you. Now, if you're not sure if what you've found is the North Star, then take a look to the left of that star you located, and see if you can locate the constellation, the Little Dipper. There are 3 stars that make up the handle from the base of the Dipper, and at the end of the handle of the Little Dipper is Polaris. Now, we know what some of you might be saying, that you could just as easily locate the Little Dipper to quickly find the North Star, but sometimes this constellation is much harder to see than the Big Dipper. Keep in mind that the Little Dipper will appear upside down to you, or as a mirror image of the Big Dipper. If you have confirmed your findings, then congratulations, you have just located Polaris, the North Star. Now, for some of you, you may not be able to see the North Star because there are regions on the planet where it cannot be seen. As one moves southward from the equator, Polaris appears lower in the sky, eventually dipping below the horizon. At the equator, Polaris is right on the horizon, making it impossible to see. In the southern hemisphere, Polaris cannot be observed at all. Now here is something really interesting that you cannot see about the North Star without a telescope that many people don't know. Polaris is actually part of a multiple star system. The primary star, Polaris A, is a supergiant with 4.5 times the mass of our Sun, and has a diameter of almost 28 million miles, 45 million kilometers. Astronomers call this star a Cepheid variable, which is the closest of its kind to Earth at about 445.5 light-years away. A Cepheid variable, also called a standard candle in astronomy, is a type of star that pulsates radially and varies in diameter, temperature, and brightness. The magnitude of Polaris makes it the brightest star of the triple star system, making it easy to see with the naked eye. Its two smaller companions are named Polaris B and Polaris AB. Polaris B, a main sequence star, orbits the primary star at a distance of about 2,400 astronomical units, while Polaris AB, another main sequence star, orbits at a much greater distance of about 18,000 astronomical units. So you're going to need a good telescope to see them. As far as the North Star is concerned, there are some pretty amazing real images of Polaris. This image was captured by the Chandra X-ray Observatory, NASA's flagship X-ray telescope. And what it imaged was breathtaking. Now if we start to zoom out on this image, we get to see the North Star's surroundings in amazing detail. Those are not earthly clouds you're seeing, but what is called an integrated flux nebula that is mostly composed of dust particles, hydrogen, and carbon monoxide, among other elements. And this image gives us an even clearer look at the nebula that appears to surround Polaris. But the surprising thing is that even though it looks like it's surrounding Polaris, it is actually located behind the star, far away from the galactic plane. Now here's an interesting thing. These integrated flux nebula are illuminated by not just a single star, but by the energy from the integrated flux of all the stars in the Milky Way. How cool is that? So now that you have a Destiny Master's degree on Polaris, the North Star, let's see what the big news is that suddenly has a lot of astronomers talking lately. They say that there is something strange going on with the North Star because researchers seem to be having a problem when it comes to measuring just exactly how far away Polaris is from Earth. It turns out that the North Star is very difficult to study and keeps breaking astronomers' models of how stars are supposed to act, and we can't really pinpoint exactly how far away it is. Astrophysicists have a few ways to calculate the mass, age, and the distance of stars in the universe, such as Polaris. One of these methods is called the stellar evolution model. With this, researchers study the brightness, color, and the pulsation rate of a star, and then use that data to figure out how big and bright it is, including what stage of life the star is in. When researchers get that all figured out, they can tell how far away that star is from us. This model is especially precise when it comes to Cepheid variable stars like our North Star, because their rate of pulsation is directly related to how bright they are, making it relatively easy to tell the distance to these types of stars. Now, when Polaris pulsates, its brightness varies because it physically gets bigger and smaller, which has to do with helium in the star's atmosphere absorbing energy. Naturally, when the star gets bigger, it's brighter, and when it shrinks, it dims. The variable nature of Polaris was first discovered back in 1911 by Danish astronomer Ejner Hertzsprung, pronounced Einar Hertzsprung. Observations of Polaris since then show that the star has had a consistent pulse period of 4 days. But this has recently begun to change, and now astronomers are wondering why this is happening. Now here's the strange part. For more than 150 years, and up until 2010, the pulsation periods had been getting longer by about 4 to 5 seconds each year. Now, for some reason, this trend has reversed, and no one is quite sure why. It could be that the orbit of the companion stars is causing the fluctuation, as Polaris B orbits close to the star every 30 years, and may be disturbing the Cepheid's outer layers where the pulsations take place. But scientists have come up with another strange possibility, and think that perhaps Polaris could have once been two stars that slammed together several million years ago. Such a cosmic collision could rejuvenate a star by pulling in the extra material and making it look like it went through some type of fountain of youth. But the problem with this is that binary star collisions, such as the one hypothesized, don't fit stellar evolution models. It is probably an unlikely scenario, however, nothing in the universe is impossible. But there is another interesting thing that was recently discovered about Polaris that could help researchers figure out what is going on with the star. Similar to how planet Earth has a magnetic field that can be detected by a compass, many stars also have a magnetic field. Stellar magnetic fields are produced by the motion of highly charged particles inside of the star, which is known as a convective dynamo. You can see the powerful effect of magnetic fields from our own sun in the form of sunspots and solar flares. But the magnetic field of a Cepheid star has never been detected, until recently. In 2022, researchers at Queen's University in Kingston, Canada, discovered that Polaris has a remarkable magnetic field. This could explain the weird pulsations as a stellar magnetic field exerts forces on charged particles in the star's atmosphere, and would impact how the star evolves and changes over time. The magnetic field of a star can be responsible for a lot of different things, such as altering the stellar winds of stars, changing their internal structure, and it can even affect the rotation speed of the star. However, little is known about the influence of magnetic fields on Cepheid stars. For one, magnetic fields are very hard to detect around this type of star due to its pulsating behavior. Researchers are saying that understanding the magnetic field of Polaris will help them understand the mysteries of the universe. We think that is a pretty bold statement, and we'll see what happens. The team that made the discovery are now going over the data, and are trying to map the star's magnetic field by getting as many observations in as they can when the star rotates across our field of view. What new things they will discover about our North Star is anyone's guess. It seems that the more we learn about the cosmos, the less we really understand.